first of all, a little bit about me. My name's Dave Pigott. I've been at Linaro for nearly 2 years now. I came from the ARM fast models team, where I actually worked on validation for the ARM fast models. My history in embedded computing is so long that when I started, it was just called computing. Sorry. I've gone too far. Okay, so lava. I've got something wrong. Oh, there we go. So, if I catch up here. So, open source software has traditionally had limited testing. Not that it's never had testing, but it's never been no concerted effort. It's mainly been ad hoc. So LAVA stands for the Linaro Automated Validation Architecture. And the idea here was to create an infrastructure so we could continually test member hardware. So the lab that we've got in the office in Cambridge is populated by lots of examples of member hardware, from every member up to some leg members. The leg hardware is slowly coming in. And what we provide with the Lava lab is continuous integration, daily builds, sort of smoke testing, anything you want to test, really. Everything gets tested on a variety of different ARM architectures. The framework itself, Lava, is open source. You can download it, branch it, look at the code, fix problems, add functionality, everything, all the usual open source stuff. And we're maintaining a large, very large, expanding farm of the latest member SoCs. So we've got Arndale boards, we've got Calzada servers, we've got a Nexus 4 in there, and there's a lot more to come. So, why use Lava? What's it giving us? It gives us the chance to validate Linaro engineering output. Everything that we do, all day, every day, is tested on a continual basis. So all the diverse range of hardware in there, so you can have your latest tests of graphics or audio or whatever, tested on a range of different member hardware. We support automated kernel testing, and one of the key points that we've got here is that in automated testing, you've got to be able to make sure that if the device somehow gets completely bricked, you can actually recover it without any manual intervention. We don't want people having to be there 24/7 in the lab. I'll come on a little bit later as to how we achieve that, because there are a variety of different strategies that make that up. But we make no assumptions of special capabilities of the device. In fact, to the outside world, the API that Lava provides is exactly the same regardless of what sort of device you're talking to. And in fact, there's a Nexus. It's not the prettiest picture in the world. It's a little bit jerry-rigged at the moment. We are actually getting proper supports and stands for it in the Lava lab. But so it's a framework for testing software on our member hardware. So it takes in a job which describes what you want to do. We don't tell you what tests you can and cannot run. We just provide you with a framework. You go through, define, I want it on this particular version of the operating system, this current cut of the operating system, the snapshot, if you will, and I want to run this set of tests, gather the results, and deliver those out back to the consumer in some way. We'll come to how we actually present that in a few minutes. But I keep iterating this point. Lava itself is an enabler. It just allows you to do almost anything you want. We do not prescribe anything. It's just a way to let you submit tests, gather results, compare notes. And basically, as I said, because this API, it doesn't matter what device is on the end of it, it's a black box. So continuous integration, everything just goes straight into it, and it's a cloud-like solution for ARM devices. You just throw it in, we find a device to test it on, and run the tests and deliver the results. Via a particular board type, and it gets run on that board, but one of those boards. We've got a farm, I'll come to the numbers in a minute, but with a lot of boards in. So typically people say, oh, I want to run on an origin. They don't say, I want to run on that origin. You can. Lava doesn't actually say you can't do that. But what you might find if you did specify one particular board is that for one reason or another, that board is offline and your job's stuck. Whereas if you just say, I want to run it on an origin, it will get done. And in fact, what's quite important is that Lava doesn't even insist that you run tests. It just says you can do things. So we're starting to work with the toolchain group so they can actually do their native compiles on ARM hardware just by submitting a job into Lava. Now we come to reliability. It's obviously, if a job fails for any reason, we have to have a high level of confidence that the reason it has failed is nothing to do with the Lava infrastructure, but something to do with the job itself. And so what we do is we run a health check every 24 hours, a board, not every board at the same time, because that would tend to overload the system, but the board itself is instructed to install a known good image of Ubuntu, boot up into it, and then a known good image of Android and boot up into it. As long as it does those two things, you're fairly confident that the hardware and Lava itself are not broken. If a board fails a health check, it's obviously taken offline until somebody can intervene and actually find out why it failed. And potentially, you might go back and look at the jobs that had failed previous to that if you found that there's a problem with the board and resubmit them. We now have a reliability of around 99% of health check pass. It's increasingly difficult to fix the final few problems, but we are working actively to do that. In fact, I'm working on one particular fix for that this week. So if something fails, if a board fails a health check for a Lava reason, i.e. there's something we're not quite doing right, then we can apply a fix into Lava itself to increase reliability. Just a quick run through for Lava workflow. Basically what you do is you define a job in a JSON file which can reference a set of instructions which Sento will cover how to do all this in his session tomorrow. In the set of instructions is a set of YAML instructions to say you want to compile something before you actually test. So you then submit that job, which goes into the Lava HTTP front end, which basically does it's a quick sanity check. Does that device type exist? and are there any syntax errors in the file. Once it's submitted, the scheduler picks it up and finds an appropriate resource, waits for an appropriate resource to come available, and then it hands it to the dispatcher and says, run this job on this board. What happens then is the dispatcher deploys an image onto that board, boots up into that image, runs your set of tests. Oh, that's embarrassing. Runs a set of tests, and then submits the results, which is viewable into the database, which then the results are viewable from the Lava dashboard. So there are different ways to think of Lava. Originally, it was conceived just as a service that we provided, the validation lab. But it's an open source project, and over time, people have picked it up. An example being Tyler, who's going to tell us all about how he picked it up and what happened. So that's Lava as a product, and we're actually, quite a few companies now are doing the work to put Lava in their own companies, running their own tests on their own hardware. And there's Lava for developers. You can actually download you can download Lava, install it, run it locally, plug a Panda board into your laptop, and run local testing. We've made deployment very easy. There's a thing called Lava Deployment Tool, which Antonio's going to tell you about on tomorrow. In fact, walk you through it. And there's Lava Test Shell, which Senthil is going to walk you through in the second session tomorrow. That's the test shell is what you actually use to run tests. So this is a quick inventory. Oh, sorry. I've got to remember to do this. Quick inventory of what's in the lab. There are a total of 87 devices of one sort or another. That's 276 ARM CPUs. The majority of those CPUs are coming from the item second from the bottom, 2 Calxeda 96 CPU servers. They're impressive things. You can see them on the right there. We're in the stages of integrating that at the moment, integrating the Calxeda servers, but it's an amazing piece of machinery and great fun. There is a small, I have the next slide, which is an animation of the usage of Lava, but because we're running slightly late, I'm going to skip this one for the moment. If anybody wants to see it, what this did was show the history of the usage of Lava from its go live date in June 2011 up until recently, but it runs for a little bit too long for me for now. So I'm going to skip that for the moment. But it does show that the usage has massively increased. So our future plans. We use a master image type approach to deploy images on SD cards at the moment. So we have a known good image that we can get back to. That's how we recover from a bricked board. And then in that image, we deploy onto some test partitions and boot into those test partitions. That means we're not testing bootloaders. So this idea of an SD mux, which allows us to talk to the SD card from a USB port on one of the servers, write the image, and boot into it, means we can actually test bootloaders as well. The Test Suite Helper tool, which is something that's coming into development to make it much easier to write a test suite. All the tools to enable you to do it much, much more simply. There's a thing called Lava LMP, the Lava Lamp, which is a set of hardware, open hardware, that's been designed by Andy Green to enable all sorts of additional functionality, external functionality to be tested, but it also happens to include the SD mux. And so we're adding Linaro Enterprise Group servers in, Calxeda being the first. I'm expecting a few more in the next week or so. And of course, we're now developing our plans for the Linaro network group, about how we're going to integrate them and what we're going to do for them. So the summary is Lava usage is growing massively. If you look at that video, it starts off with like 2 boards and 3 people, and it gets towards the end and there's hundreds, well, not hundreds, tens of boards and hundreds of people and automated processes interacting with it. The interest is growing. We're getting people outside, people like Tyler and some of our partners taking it in-house and running it themselves. And the Lava Lab is expanding. We are currently at 5 cabinets. You saw all the hardware. When I get back next week, we're taking delivery of 2 more cabinets to take a lot more hardware. And trust me, there are enough requirements to keep us busy for a long, long time. Anyway, now I'm going to hand over to Tyler, who's going to tell you about his experiences.
Dave?
Let me just switch you across.
Include the mic. His mic.
Oh, okay, sure. Oh, yeah. There you go.
Thank you.
Right. There we go.
Perfect. Get that out of your pocket.
Oh, yeah. that could be embarrassing.
No problem. Thank you. Good afternoon. Can everybody hear me okay? Yeah. All right. I'm Tyler Baker. This is a Lava success story. So I'm pretty new to Linaro, so I want to give you some background of what I've been doing before I've come here. I was an Android platform developer. I did BSP work, a lot of driver development, a lot of driver integration, lots of stuff with radios, so WLAN, WWAN, real integrations. I also teach for a company called Maracana, who teaches about open source software, and I'm Android systems internal course instructor. I also graduated from Western Washington University in applied mathematics and computer science. And some hobbies. I'm really looking forward to the whole drone movement, so I play around with autonomous aerial drones. I also like fishing and snowboarding. And I'm located in the Pacific Northwest in the United States, about an hour north of Seattle, in this little town called Bellingham, Washington. So what I want to do is give you a perspective from an outsider who's now part of Linaro, being that I worked for an OEM integrating TI's SoCs into products and developing, rugged, embedded mobile handsets that ran Android. So I have a unique perspective in the sense that I'm a developer, but we got to a point with the company where they wanted some validation of the platform we were building, because this is sort of an unknown quantity to them. They were more of a Windows mobile house. We were transitioning over to Android. So they weren't sure how to quantify the money they were spending without any validation. So I want to talk a little bit about my continuous integration philosophy, why Lava was adopted, and how it can be integrated into CI environments, and why everybody in this room should consider using Lava. So that's kind of the takeaway points from this presentation. So let's start with a little calculus. I like to think of CI as a limit as x approaches 0 of 1 over x. And the idea behind this is, let's think of CI as the asymptote, right? We can infinitely approach the asymptote, but we'll never get there. So really, you want to get as close as your return on investment allows. So like Dave was saying, with the health checks, 99.99% of health checks pass. How much further do you really want to go? It's what's your return on investment? So I like to think of CI as some kind of a, well, not really a moving target, but something that's not really obtainable, but we can get really, really close to it. So, and again, achieving true CI is very difficult. There's always something else that can be automated. I hear that all the time. Well, you're not automating bootloader testing, or the signal attenuator is not automated. So, it can really, the scope can creep out very far when you're talking about CI. So you really need to look at what that means to your business and your product, and how to define where that line is for you. So every team, every company is a little bit different, and just want to make that point. So in my opinion, the best approach to CI is to evolve your strategy. Technology changes very quickly. The tools change very quickly. Be adaptable. Be open-minded. And that's basically my philosophy. So let's talk about automated test frameworks that already exist in the world, some of the pain points. So I was approached by many SoC vendors, third-party software vendors to say, hey, use our automated test framework. It makes the most sense. And here is my gripes with it. Intellectual property. They thought that there was so much intellectual property in their test automation frameworks that they closed down the source. We had to pay these outrageous licensing fees, costly integration efforts. And I had one company say $100,000 for devices. We send an engineer in, $50,000 to integrate it into whatever CI system you have, and it's $25,000 per year after that, just to do 4 devices with CI. And I looked at the management team and said, that is absolutely ridiculous, in my opinion. So they said, well, what are you going to do? I mean, how are you going to solve this problem that we need? And I needed a system that was scalable, extensible, and I need something to report to upper management. So I needed some sort of a dashboard that could record like key performance indicators, because that's what the management wanted to see. They wanted to trend certain measurements over time so that we knew how our product was doing, whether our I/O speed all of a sudden was going down, and we could track the change back, and management would be up in arms saying, you're not ready to release yet. You're not meeting the I/O requirements in the spec. So how did I get involved with Lava? I actually watched it at ELC 2011 when it was kind of unveiled. I said, hey, that's a neat idea. I'm going to go check out the software. It was pretty raw at the time, but I was working on a rugged OMAP 3-based handset and decided, hey, they're working on the Beagle board. I'm sure we can take some of what they've done and kind of adapt it into our environment. And I did just that. And really, the reasons were it's flexible, has flexible architecture, so that the dispatcher can be run on its own. All the test runners can be run on its own, or you can just run the web pieces. It was easy to extend, and automated recovery of brick devices. That was big for us because being that we were writing bootloader code, we need to be able to recover very quickly. And kernel drivers that could potentially crash the kernel, we need to be able to recover from that. So that was a pretty hard requirement, and Lava seemed to have a pretty good start to that. There's a lot of tests that were already integrated. Obviously, it's open source. And really the key point here is Lava is an enabler. It didn't really dictate that we have to use this programming language per se to write tests. It could be a test written in another framework that we could just use Lava to run on the device. And that was the key, is that we weren't really tied down to one sort of programming language or one type of test. So, and then contributing changes upstream reduces technical debt. And really that's a big thing, because some of the other automated test frameworks that were out there said, well, you can write these modules, but we're still working on it. So you can write a module today, and in 3 weeks you might have to rewrite your module to make it work with the next release. And then you're incurring technical debt because you have to maintain the system. So we decided that it would be a better model to use an open source project and try to upstream any core changes we made to the core of Lava. And if anything that might be not accepted by the upstream, we'd put as an extension, so that we could maintain that as a part, or as a separate part of Lava. So Lava extensions, let's talk about extensions for a little bit. They're basically command line tools that are wrapped and exposed as actions to the dispatcher. So you can take any command line tool you want, put a wrapper around it, and expose it to the dispatcher, and you can actually write a schema that says, well, I want you to take these parameters, and that's how you automate what you're doing in the job file, as Dave was talking about. So it was very simple to extend the existing software that came with Lava once you understand entry points. Once we got our heads around that, we said, okay, well, I think we can take this and make this work for what we're trying to achieve here. The other thing that was big was developers who write system services or applications needed to be enabled by Lava, and so that they could take advantage of the testing framework. So the issues that needed to be solved were facilitating the downloading, installing, uninstalling of applications and system services, being able to deploy and download files onto the file system, run commands client-side over ADB, because we were developing an Android product, run unit or functional tests, and get the results. So those were the problems that we needed to solve that Lava wasn't solving for us already. Just because it's a little bit more platform-centric, which is okay, and I understand that's why it is, but there's no reason it couldn't be extended to meet these needs. So the first thing we did, extended Lava Android test. And what we did is an extension called deploy this. And what it does is that you provide me a link on the file system or HTTP link to the binary. So it could be a file, it could be a library, it could be an APK. And I want you to put it here on the system partition or the data partition or wherever you'd like. And what it would do is it would download it, it would push it over ADB, and then that was all we wanted it to do. So then we needed to say, well, okay, I need to be able to build a kernel module external from my build, push it onto the device, and give it proper permissions and insert it into the kernel. So we extended it again, called run this, which is basically allowing you to run client-side shell commands as a root user so that we could push the kernel module, insert it, give it proper permissions, and basically set up the device for a particular test. Because we want this to be modular, right? We don't want to say, well, we just have these really complicated dispatcher actions that go and do this for you. I'd rather just let the developer be able to describe this in a job file. That way it's more generalized and it's more of an interface rather than you relying on pre-built actions to do everything for you. So we also extended it to use Google Test and JUnit, and this was actually really powerful because application developers who wanted to test their applications that would write unit tests or functional tests were using these frameworks already. So we had the Google Test binaries just sitting around in our build server, same with JUnit APKs. So it did the same thing. It downloaded, it installed, it called the intent to either start the JUnit or invoke the G-test, and then we wrote the regular expressions to parse the G-test and the JUnit output. And so now the test results would be submitted to Lava. They look like any other Lava test result, but it was a dynamic fashion. So you could say this JUnit APK here and this Google Test binary over here, and it could be a web link, it could be on the file system. So it allowed developers to just set up an Apache web server on their local machine saying, well, here's my IP address and here's where the binary lives. Go pull it down and run it for me on a device and then send me back the results. So with all of these tools, we were actually able to test Android over-the-air updates with Lava, which is kind of a concern. Is how do you do that? Because you can flash with fastboot, but you can deliver to a customer with an over-the-air update. So how did you solve that problem? Well, it turns out this is all we needed to solve that problem and to test it properly. This is more of a corporate environment problem. How do you authenticate user accounts with the existing corporate environment? So at our particular company was LDAP. So we looked at the open ID authentication implementation that comes with Lava and basically extended it to work with LDAP. It took us a day to do. It's very straightforward, writing a server extension. I'm an embedded guy, and I was able to go in there and do it. So take that as you will. I'm not much of a web programmer. So it was very straightforward. And this just goes to show that it can adapt to almost any need if you have the engineering ability to do it. So let's talk about some CI integration now. So Lava and Jenkins, we chose Jenkins because it was open source and it was pretty well-known quantity at the time. So having Jenkins schedule a Lava job is really trivial, right? It doesn't take a lot of brain power to do it. I think everybody can get their head around that. The problem is it's an asynchronous operation. You submit a job, it's gone. Right? You don't know what's happening. Is the test passing? Is what's the status of the device? None of that was built in. So, and the Lava dashboard holds all the test results, which is fine. But this really breaks the rapid feedback loop policy of CI, where it's I'm a developer, I want to check a change, I want quick feedback, and I don't want to go look some other server to go find the test results. I want it in the place that I checked in the change. So that was kind of the rationale behind driving this whole CI integration. So we wanted something that was very tight, that was very fast, that developers would use because it gave them value. It wasn't something that they had to do so they could make a checkbox in their next management meeting. This is something that they actually ended up wanting to use. So there's a couple issues with that, and I'll kind of just lightly go over them. Is basically these job files are a static thing. How do you create them dynamically? So there's some issues there. With CI, and we solved some of them. It may not be the best implementation, but it works. So we extended Lava tool, and we added a function called test job run. Now this blocks like a synchronous operation. It monitors the job, and when the job completes, the results are fed out to standard out. Now, in our first iteration, we fed all the test cases out to standard out, and that was good, but there was a lot of data. So we ended up saying, well, just the failed test cases. That's all we really care about. And then we put in another option to output the results in XUnit format, because that was an established test result format that there was a lot of visualization built for already within Jenkins. So not only can you do just graphs in Jenkins because you have XUnit, but you can actually drill down into the actual test case results, just like you would looking at a Lava results bundle, but in Jenkins. So that was a good step forward, not really solving all of our problems, though. Another big thing for these big companies, they've already invested in some test results database. So there's a lot of requirements that, well, that's fine, you can use this test framework, but I need to see the test results in this particular database. And dumping it to standard out or putting it into XUnit allowed us to integrate with other existing test databases that our company had. So this is what it looks like. So this is some of our platform components. And you can see there's 450 test cases we're running on every commit. And the ones where there's nothing there means the first one failed, so it stopped. So you can start to see some visualization in Jenkins. And then this is kind of a drill down. I know you guys probably can't see this, but I'll post my slides if you want to have a closer look. These are the actual test cases, and it tells me how many passed and failed, much like you would see today in a current Lava test bundle. So let's take it a step further here. Actually, maybe we'll talk about the job files. Basically, we're using sed to replace variables. So in Jenkins, you have a set of environment variables like Jenkins URL, Jenkins build number, so that I can actually dynamically reference the binary that just got built in Jenkins when I schedule a job. So it's actually pulling the artifacts out of Jenkins dynamically, and it's creating this new job file that gets submitted on the fly. And that's how we kind of worked around it. It's probably a bit of a hack, but it was very, very robust. We haven't had a problem with it. There were other problems elsewhere that needed to be solved. So we kind of just said, we're going to just use this. So then we said, let's take it a step further. Let's modify the job templates, let's get them scheduled, and let's pump the results back into Garrett as a code review. So that's what we did. So Jenkins, as you might know, can listen for Garrett events. So a change merged, a change, patch set uploaded, right? And those were our triggers for our development builds and our integration builds. So what was very unique about this is once it was triggered, Jenkins would build, a downstream Lava job would kick off that would block and monitor the test job. And when it was done, since it had all the environment variables from Garrett, like the change set number, it would we wrapped it with the thin bass wrapper that uses the Garrett SS API to go and code review the person that kicked off the change. So if you got a failure of any test case, it would say -1. I prefer you didn't submit this. And here's the test case that failed. And here's the results link to the Lava dashboard. So that from Garrett, a developer could click on it and go and see what tests failed and look at the definition and look at the log and understand perhaps maybe why that was failing. We also implemented dumping out the kernel messages in a case of a driver failure. Obviously a +1 if all the test cases passed. If there was incomplete, meaning the device didn't boot for some reason, we'd say mark it 0, because on early hardware, it was kind of a pain that everybody was getting their commits marked -1 when the hardware wasn't booting. So we had to kind of do a workaround there. But this is what CI is all about, right? It's getting developers quick feedback that's not a pain to use. And that's what we really strived for when we did this. So again, the pictures are a little hard to see. But what's important to notice here is that on every single commit, we're getting a build and we're getting a test and we're getting results fed back in. And if you notice at the build time, if you want to take a closer look at this, so our builds for a full Android build, bootloaders, kernel, file system, we got it down to about 4 minutes on this particular one. But we're deploying, so we're actually burning the file systems in, loading the kernel into RAM, jumping to it, running our test cases, so 450 test cases in 8 minutes. And that's getting the results back into Garrett in 8 minutes. And you can see the timestamps here. So this is when everything's going well and developers are passing all their test cases. Now, if we go here, this is where one of our developers was having a hard time with one of the functional tests, which was scanning a barcode with some of his code. And this is basically what you get. Here's a test case, and here's the actual test that failed. And then there's the result link, so you can go in there and start investigating right away. So kind of an overview of how this works. We worked with a lot of third-party software vendors. So we had a requirement that we have an external CI loop to basically sandbox them. And internally, we had our own CI loop. But we used a common Lava server. So you can see that the build triggers and the change sets came down through here, got built. And then all got fed into a common lava pool with a common device pool. So we were able to leverage a single lava server and a single device pool, which was really nice. And then the test results kind of feed up through the middle here back to the developers in both cases. So whether you're working with us internally or externally, you were getting the same benefit of our CI system. Canary testing. Okay, so let me explain a little bit about canary testing. In the coal mines, I'm not sure if they do this to this day, but they were worried about carbon monoxide. So they take a canary down with them, and if the canary died, it was very sensitive to carbon monoxide. You knew it was time to get out of the mine because there was toxic gas in the air. So we call this canary testing. And when you're doing embedded systems, there's a good chance that you need to recover from an OS build, like somebody puts something in there and we get a kernel crash. Well, we don't want that being pushed out to a larger set of devices. So we had this idea of canary testing where we had, I think, 16 devices using fastboot with lava to test all of our kernel changes, anything to the file system. And basically, once we'd run it through the canary test, we'd say, okay, this met our quality requirements. Now we can push out to a larger pool of devices as an over-the-air update so that we had the confidence that we weren't going to push out a bad build that bricked all of the developers' devices that were hooked up over TCP/IP. So check and said, what do you need to do this? And I said, I need a lot of horsepower. So I got to hand build some really nice Xeon servers to build Android really quickly. So we built it on a RAM disk. It was 18 minutes from a clean tree on 4.21, which is phenomenal. In fact, I've been tracking Android builders groups, seeing if anybody has beat my time yet. I don't think they have. And so basically, we're smoke testing all of our builds on these Canary units, and then once they pass a certain level of quality, we push them out to a larger device pool. This is what it looks like. So these are our custom rugged devices. They're OMAP 4 based. They have their own custom dock, but we have this all under power control. So if something were to go wrong, we could reset it, get it back into fastboot mode, and on with the next job. This is the server I got to build. This guy is the workhorse for the whole CI loop. You really need this close interaction. So, multi-core Xeon with lots of RAM. So just to show how much more extensible Lava is, we added support for other operating systems, other inferior operating systems that were out there, like Windows Mobile and iOS. It was something that was actually really trivial once we understood how to utilize Lava. So it can do the same thing on Windows Mobile, flashing the OS, running tests, reporting results, just like it happens on Android or in the validation lab in Cambridge. So actually, these are a little bit old. We do have iOS support now, obviously we have to jailbreak the device, but it does work in Lava, so it's just kind of a proof of concept there. So conclusion, everything, all the extensions that I mentioned here, I'm going to work with the Lava team to get upstream so that we can all have the benefit. I think some of the Android guys might really benefit from some of these tools as I'm talking with them this week. So we want to get that upstreamed in the mainline Lava code. We want to do it in the cleanest way possible. I don't want to put any extra burden on anybody else. So I think that's going to be a task for me this week. Lava may not do everything you want today, but it can easily be extended. And I hope that everybody, that's the takeaway from my presentation, is that it's extensible. Lava has a great team of developers out there. And obviously, Lava can be tightly integrated into a CI environment. So I guess my 5,000-foot view of Lava, what I'd like to see is it become the gold standard for testing open source software projects. So Cyanogen mod, right? All those nightly builds that are just hanging out there. We could show those guys. I mean, I don't know if anybody else in this room ever flashes a Cyanogen mod, but the first question is, well, does the camera work? Does the Wi-Fi work? What's the status on the WAN radio? Well, I'd love to know if we could just have their nightly builds being tested on some of their hardware and show them, hey guys, now you can provide to the community basic validation that the ROM that's built nightly is acceptable for daily use. So something like that is what I'd like to see Lava kind of fit in as far as the community goes. So thank you. I know I've kind of rambled on, but I'm new to Linaro, so say hi to me, introduce, catch me on IRC, it's Tyler-Baker. Then I wanted to just reiterate one thing. Hands-on tomorrow. Please follow this link. I think we're going to probably send out an email or we'll share the slides out. Make sure you have the VM image before you come in here. That way we're not waiting on people to download the image. And like Dave said, we might have USB sticks. We're not really clear on that right now. And that, make sure you email this if you're going to show up, just so we kind of have a head count and try to plan for appropriate resources to be there to help you guys out. So thank you very much.